Good morning, students. Today we are going to learn the chapter Measures of Dispersion, and today's topic is range, mean deviation, standard deviation, and coefficient of variation. Measures of dispersion. Dispersion is defined as deviation or scattering of values from their central values, that means average, mean, median, or mode, but preferably mean or median. Mean means sum of all observations divided by number of observation. Median means central value of our data after arranging the ascending or descending order. Mode means frequently coming the same number of observations more times in our data. It is known as mode. Dispersion discovers variability in uniformity. In other words, dispersion measures a degree or extent to which the values of variable deviate from its average. Dispersion indicates the degree of heterogeneity between the variables, and as heterogeneity increases, dispersion increases. If all values are equal, then any measure of dispersion is always zero. All measures of dispersions are positive. All measures of dispersion are independent of the change of origin, but dependent on the change of scale. All prerequisites of a good measures of central tendency are equally applicable for good measure of dispersion. Some distributions may have same central tendency and same dispersion, different central tendency but same dispersion, same central tendency but different dispersion, and different central tendency and different dispersion. Types of measures of dispersion. There are two types of measures of dispersion. One is absolute measure, second one is relative measures. In absolute measures, these measures of dispersion will have the same units as those of the variable, and relative measures, these are usually expressed as ratios or percentage and hence unit free. Absolute measures are related to the distribution itself, and relative measures are used to compare a variability between two or more series to check the relative accuracy of the data. Measures of dispersion. A good measure of dispersion should obey conditions similar to those for a satisfactory average and are as follows. It should be rigidly defined. It should be based on all observations. It should be readily compressible. It should be fairly easily calculated. It should affected as little as possible by fluctuations of sampling. It should readily lend itself to algebraic treatment, and It should be is effective by the presence by extreme values. The flowchart indicates the measures of dispersion. Two types of measures of dispersion. One is absolute and second one is relative. Absolute measures of dispersion are further classified into four different groups and are range, quartile deviation, mean deviation, and standard deviation. Relative measures of dispersion are again classified into four different groups. First, coefficient of range. Number two, coefficient of quartile deviation. Number three, coefficient of mean deviation. And number four, coefficient of variation. Range. It is the quickest measure or finding out dispersion. It does not depend on all observations. It's a crude method of finding out dispersion and most unreliable. Range is unaffected by the presence of frequency. A range is independent of the change of origin but depends on change of scale. For simple series and simple frequency distribution, a range is equal to highest value minus lowest value of our data. For grouped frequency distribution, a range is equal to upper boundary of last class minus lower boundary of first class. A range is equal to upper limit of last class minus lower limit of first class plus 1. Mean deviation or mean absolute deviation. It is based on all observations and hence it provides much better dispersion than range and quartile deviation. Mean deviation of a set of values of a variance is defined as the absolute mean of the absolute deviation taken about mean, median or mode. Absolute deviation implies a deviation without any regard to sign. If nothing is specified, mean deviation will imply deviation about AM only. Since sum of deviations is least, when deviations are taken about median, hence MD about median will have the least value. Mean deviation is the independent of the change of origin but depend on the change of scale. Standard deviation. It is the best measure and the most commonly used measure of dispersion. It takes into consideration the magnitude of all the observations and gives the minimum value of dispersion possible. Standard deviation has all the prerequisites of good measures of dispersion except the fact that it gets unduly affected by the presence of extreme values. It is also known as root mean square deviation about mean. It is denoted by some standard deviation square is equal to variance is equal to square deviation. If all observations are equal to variance is equal to standard deviation is equal to 0. Standard deviation is the independent of the change of origin but dependent on the change of scale. Coefficient of variation. It is calculated by standard deviation divided by mean multiplied by 100 is equal to sum of 100 divided by x. Coefficient of variation is the best relative measure of dispersion. Coefficient of variation is used to compare variability of consistency between two or more series. More coefficient of variation implies more variability, indicating thereby less stability or consistency, and vice versa. Regarding choice of an atom, always choose that atom which has less coefficient of variation, because the atoms with lower coefficient of variation is more stable.